Alright, here we're going to be graphing absolute value functions. So an absolute value function is a function that contains an algebraic expression within absolute value symbols. Recall that the absolute value of a number is the distance from 0 on the number line. So let's start by graphing the parent function, which is just the absolute value of x. And we're going to go ahead and use an xy table. And we'll go ahead and use the values -2, -1, 0, 1, and 2. So the absolute value of -2, that's going to be 2. Absolute value of -1 is going to be 1. Absolute value of 0 is 1. Absolute value of 1 is also, there should be 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So we get the points -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Alright, so let's go ahead and label. Alright, and our first point is 0, 0, 1, 1, 2, 2, and then -1, 1, and -2, 2. And it's going to be a V-shaped. So the absolute value will always be this V-shaped. And from here, we are going to do transformations. So in the following chart that I have here, it goes ahead and shows you what all the transformations are. So we have vertical transformations, which is when it's on the outside of the absolute value. And then horizontal translations, when it's on the inside and it's being added or subtracted for both of those cases. And then when it's multiplied outside, that's going to be a vertical stretch or compression. And then when it's multiplied inside, it's going to be a horizontal stretch or compression. And then when we're talking about a negative, when it's outside, it's reflection or across the x-axis. And when it's inside, it's across the y-axis. Okay, so we're going to go ahead and graph these. So let's go ahead and start off with maybe doing the transformation. So I'll have 3 different colors. And let's talk about the transformation. So this is inside and it's being added. So it's actually this one. And so if you notice, this says -2, but it says 2 units right. So whenever something is inside, we're always going to do the opposite. So this is actually going to be 2 units left. All right, then this next one, it's absolute value of x plus 2. So it's on the outside and it's being added. So it's this one right here. And when it's on the outside, it's just whatever it is. So 2 units up. All right, and then we have multiplication on the outside. So that's going to be this one. And so that's going to be a, when it's bigger than 1, it's a stretch. Less than 1, it's a compression. And then for this one, it's actually the opposite. If it's bigger than 1, it's a compression. And if it's less than 1, it's a stretch. All right, so this is going to be a vertical stretch by 6. Okay, so we could go ahead and graph those. So what we probably want to do is we probably want to graph the parent function. I'm going to go ahead and do that. You could copy that over from your notes. And we will dot that one since that's just the parent function. Okay, and then let's start off with the blue one. So it says 2 units left. So you're going to take each one of these points from the parent function and move them 2 units left. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and then there it is. So that's the first one. And then the next one, we'll graph it in green. So 2 units up. So each one of those, okay, from the parent function, you're going to move it 2 units up. So 1, 2, 1, 2, 1, 2, and 1, 2. All right, so there is the green one. And then vertical stretch, let's just say by 2. So vertical stretch by 2. That means you're going to take those values and you're going to move them twice. So basically, this distance right here was at 1. You'll move it to 2. The 0 will stay the same because you can't double 0. And then 2, the y value here is 2. So you're going to double it to 4 because you're going to stretch it by 2. Okay, then you'll do the same thing over here. So this was 1. Basically, you're multiplying it by 2. And then the next one, stretch it to 4. And then that would be your answer. So there are your 3 graphs for example number 1. Now let's go ahead and do one that has 2 transformations. So this one right here, the transformation is this part and then this part. So let's go ahead and do the blue first. So that's going to be right 1 unit because it's on the inside. So we're doing the opposite of what it is, and then we're either going, when it's addition, it's either up or down or left and right. All right, and then the plus 3, because it's on the outside, it's going to be up or down. So up 3 units. All right, so we're going to go ahead and graph the parent function. And again, we're going to go ahead and just dot that. All right, and then we're going to go ahead and graph this one. So I'm going to move everything right 1 unit and up 3, all at the same time. So right 1 unit and up 3. There's the original. All right, so I went ahead and moved everything over. Right 1 and up 3. And then I'm just going to go ahead and erase that scratch work. And then that's it. That's my transformation. All right, so next we have this one right here. So negative absolute value of x plus 3. So let's go ahead and start off with our transformations. So we have this and this one. So this one right here, if it's on the negative on the outside, it's a reflection across x-axis. And then this one is going to be up 3 units. Okay, so we're going to again go ahead and start off with the parent function. And then we're going to go ahead and do the transformations. So notice if we reflect across the x-axis, we do get the same image. So we're just going to go ahead and move 3 units up. All right, so we moved each one of our points 3 units up. And that would be our final answer. All right, so that is it. One last thing we want to talk about is domain. So let's talk about the domain and the range. So remember, the domain is the x values, and then the range is the y values. So the corresponding x and y values. So your domain for this blue function, is going to be basically all real numbers because it's going everywhere to the on the negative side and the positive side. And then your range, it's where the y values are. So I like to basically do like a little, take my pencil, and I'm going to show you with the highlighter, but kind of move it all the way here until I hit the graph. Okay, there I finally hit the graph. So it starts at 3 and then it goes all the way to infinity. Alright, actually I wanted to do one more example with you to find the domain and range. So let's go ahead and talk about the domain of this first one. So remember, again, domain is the x values. So here your graph is going in both directions to infinity. So to the left and the right to infinity. So it's going to be all real numbers. And then your range, again, I like to look at that pencil. And alright, that is where it starts at. So it starts at 0 and it goes all the way to infinity. Okay, alright, and then the next one, domain, again, it goes forever in the left and the right direction. So it's going to be from negative infinity to positive infinity. And if you notice, these are both absolute value graphs. So for the absolute value, your domain will always be this. Alright, in the range, see, now because your now because your graph is facing down, you actually want to take your pencil and start from the top, and it hits 3 first. So you're going to go to 3 first, but then, oops, sorry, not 3 first. Your 3 is going to be on that outer edge, and then negative infinity because it goes all the way to negative infinity. But remember, with interval notation, this should always be the smallest one. So negative infinity is smaller than 3. That's why that one's on that side. And that is it.